Well, good afternoon. My name is Andrew Waterhouse. I'm director of the Robert Mondavi Institute. And this is the inaugural event in the new UC Davis series forum, Talks on Food and Wine Science, the very first one. So welcome all to the very first event of this type. This evening's topic is one of the most popular amongst food lovers today, and that's obviously why the room is so full: fermented foods. We're rediscovering the importance of the microbiome, including on the foods we eat, and of course the very interesting tastes of fermented foods. More specifically, this event focuses on pickles and the bacteria that create them and related foods. But fermentation is based on a wide array of microbes that have been used for centuries to preserve perishable foods. From cucumbers to grapes to grain, and that's beer, by the way, milk, and even meat. In fact, Patrick McGovern, who studies fermentation, has made the claim that fermentation is the foundation of civilization because it allowed the preservation of abundant calories, leaving producers with a little bit of time on their hands to think about things like their history and their legacy. So this series is an important addition to campus conversations about creative work at UC Davis and our region. UC Davis has a mission of excellence in education and research, and part of that mission is to disseminate that new knowledge and understanding with other experts, with the public, and through events like this. Specifically, the Robert Mondavi Institute has a goal of being a prestigious forum for discussions like this. And I hope you'll come away with a better understanding of the research and teachings that happens here. By the way, graduate students, if you're not familiar with them, are really the hands that do all the work and the research. And in doing so, they learn to be the research leaders of tomorrow. And I hope you also come away with an appreciation for the impact that our research has on society. So to start tonight, I'd like to introduce our first speaker, who's Maria Marco. She's a professor in the Department of Food Science and Technology. She received her bachelor's degree in microbiology from Penn State University and her PhD from UC Berkeley, where she actually studied plant science. But she actually studied the microbes that are on the plants. I thought that was pretty interesting. After she finished her degree there, she went to the Netherlands, where she worked as a lead scientist at a dairy research institute called NIZO. And you'll have to ask her to explain what those four letters mean. I noticed that when she came to Davis, she brought her Dutch bicycle with her, and a bike that she rides nearly every day. She has an internationally recognized research program in lactic acid bacteria, in the ecology of food and the gut microbiota. This research has received over $10 million in research support from federal, state, foundation, and international agencies. She's mentored over 100 students, postdocs, and visiting scientists in her lab. She has over 70 publications in peer-reviewed journals and numerous patents. And in addition, a busy woman, she's the founder of a startup company on microbial detection. She received an American Society for Microbiology Distinguished Lecturer Award and serves on numerous advisory and editorial boards. She's also very interested in educating the next generation of research leaders and is currently chair of the graduate group in food science, where there's about 70 students in the program. Lastly, before she starts, I'll just mention that she learned about fermentation from her grandmother. So, Maria.
Thank you for that introduction, the kind introduction, and welcome to UC Davis. It's great. I see familiar faces, and I see new, hopefully, friends we have at the end of this hour. It's really a pleasure to be able to communicate, to describe the work that we do, and to kind of share the passion we have here for our work and our fermented foods. And I think that is an easy sell. I love fermented foods. And I want to start out with kind of a big picture on some challenges we're facing globally in the 21st century. You'll see how this brings us to fermented foods. So we know that agriculture has major environmental impacts. We know that approximately 1/3 of all food that we produce around the world is lost either to spoilage or to waste. We know that food production is not meeting the demands of population growth, and we know that our food systems are not always delivering healthy diets. These are 21st century grand challenges that we need to address. How are we going to address them? By fermented foods, of course. Okay, well, maybe not every aspect of that, but the way I see it, fermented foods and beverages offer a lot of opportunities, ancient foods we can return to seek new answers. For example, new food ingredients, new foods and beverages that we haven't thought of before, or tweaks on what we already know. Increased shelf lifetimes, delivering foods that maybe don't require refrigeration. Diversify products, and personalize our nutrition. We're all thinking about what foods we can eat that will keep us healthy, make us healthy, live a long life with well-being and happiness. So how do we, through fermented foods, I'm going to achieve this? So what are fermented foods? These are foods and beverages that are made as a result of extensive microbial growth. That's it. All we need is microbes, the right kind of microbes, the right time to get our fermented foods. So we start with very simple ingredients. We start with milk, meat, fruits and vegetables, grains. We do very simple things to those starting materials, those starting ingredients. We can chop them, we can salt, we can spice it, we can pack it. Very simple things we do make a tremendous difference, because what those things do is they give access or remove access to microorganisms to those foods. Depending on the food that we start with, we're going to maybe release polysaccharides or monosaccharides. We're going to different sugars, different proteins and fats that are inherent to the properties of those foods. By doing so, we encourage or discourage the growth of different microbial groups. Lactic acid bacteria, which I'm going to mention here, as well as yeast, are enriched when we have starting materials that are high in simple sugars like glucose, fructose, sucrose. On the other hand, we have foods that are rich in polysaccharides, fats, proteins. We're going to get enrichment of molds, as well as other bacteria besides lactic acid bacteria, but you see lactics are still there. So this very simple process, we didn't know what we were doing when fermented foods were starting to be made approximately 10,000 years ago. What that ended up, though, with is the periodic table of fermented foods. And I'm sure you can't read it, but I love showing it. And each member of the table here represents a different fermented food. You can contact me if you'd like to receive this. It's pretty fun. But we know we have thousands of different kinds of fermented foods, over 3,000 different types of cheeses, all from this very, very simple process. We don't even necessarily give much thought to when we're making them, because it's just how we prepare foods. And we know cheese, wine, beer. Now we're seeing, if you go to maybe restaurants around the world, like Noma in Copenhagen, really taking a spin on making new kinds of fermented foods, like fermenting crickets or old bread. So this has touched the imagination of chefs around the world. So why are not fermented foods eaten more? Why do we not maybe have the center of our agriculture on fermented foods? There are issues, and so that's why I want to point out in my talk. So one of those issues is expanding the production capacity of a fermented food. What kinds of issues do we run into that could limit the growth of this really important sector in our food supply? And the other thing I want to touch on is, are these foods healthy? How do they fit into our diets? Do they give more than just basic nutrition? So I'm going to start by talking to you about this idea of scale-up. The issue we have with scale-up in fermented foods is that they are alive. When we're talking about living organisms, we're talking about people, and it's hard to control people. It's hard to control microbes too. So they have the minds of their own. So these living foods are vulnerable to having problems. So my example here of two, the first example is with making fermented olives. So about an hour and a half north of here, we have the only commercial olive fermentation industry, businesses, in the US. The particular olives that they're fermenting there are Sevillano olives into Sicilian style, and we'll often find them in olive bars stuffed with maybe blue cheese or garlic. So you see them over here. And just as an example of how these foods are alive, what happens when the olives are submerged around September, October every year, they're submerged in salt water and some vinegar. Within a week, we see the growth of lactic acid bacteria, the dominant bacteria and microbes on these foods, from undetectable on the olive to over 10 million cells per gram olive. We find similar numbers in the brine. These fermented olives also require yeast, so we also see yeast. Natural yeast populations grow quickly in lower numbers and are sustained throughout the fermentation. You can see here this goes on for actually about 9 months before these olives are ready. And what you see here on the right is a pellicle formation, natural mat that's formed between the yeast and the lactic acid bacteria in these fermentations. Using modern methods in microbiology, we're able to probe into not just in the numbers of microbes there, but who they are. And that's a really exciting area if you think about the gut microbiome or the microbiomes of our planet. We're using the same methods as we're using here to interrogate, ask what microbes are in fermented foods. And what you see here is, although those numbers of yeast and bacteria went up quickly and stayed high throughout the fermentation, what you should see is that there's a change in the microbial composition over time. It's not a static environment. It's a dynamic ecosystem where the microbial groups change among the bacteria, on the olives, and over here is on the brine, a different group of lactic acid bacteria, and amongst the yeast as well. So we wouldn't be able to tell you that before these modern methods in microbial ecology have been now available. You can imagine, this is a tough environment in order to control. So one of the things we've been tackling with these fermented olives is a problem that you see here. You see olives that are really mushy, so mushy that you really can't sell them anymore. And I didn't think it was microbial when I first saw this. I thought maybe they had picked old fruit. But it was microbial, proved me wrong. And we were able to identify the smoking gun, that the microbe that caused the problem was a group of pectinolytic yeast. So yeast are, like I said, are natural members of the fermented olive microbial community. But we had a rogue yeast that's able to degrade the mesocarp, the tissue of the olive, so much that nothing was really left. We were able to show that through experiments where we take the isolated yeast that has this pectinolytic activity, we inoculate it into olives, and then we wait through the fermentation. And what we see is measuring here as the force of pressure we have on the olive as we're able to compress it more. That means it's a softer olive. And normally olives, we don't want them to be too hard. If you ever pick them from the tree, they're very hard. So the yeast help degrade or help make that olive softer, so we want to eat it. But what happens when we add the pectinolytic yeast here, we see that they're too soft. We're able to show, again, with microbial DNA sequencing methods, what we're looking at here, we're able to find the Saccharomyces cerevisiae strain we inoculated back, but it's still a small number of the total microbiota in those olives, which was kind of strange to us since we saw so much degradation and loss of the structure of that olive. Now, I wish I could say we had the solution, we found the cause, we're still looking for the cure. So that is sort of the Achilles heel, one example of an Achilles heel in making fermented foods in mass. Right? We might make them at home, but well, how do we scale up and make these foods so that everybody can enjoy them? And so we're still struggling with that. So my second example, moving from fermented plant foods to dairy. Fermented dairy foods, we think of cheese, yogurt, kefir, for some examples. And we know that there's a lot of microbial inputs into foods, just as we would have into fruits and vegetables. We found that raw milk is a real microbial zoo, and one can imagine that milk exposure on the farm from the dust in the air, the bedding of the animal, transport, and what we found is that there's a lot of diversity in raw milk. Of course, it's pasteurized, and so this diversity is largely gone, but we were studying this in California to understand what is the microbial composition of milk and how might it change over different times of year or in different locations in California. And what we found is that the bacterial content of raw milk is pretty similar in different parts of California, although what we do see is that there's a seasonality to it, so the bacterial composition of milk will change depending on the time of year. And so what we're looking at here with these complicated graphs is just an overview of the bacterial diversity in the milk, and where you see different splotches, that's indicating that there's different bacteria present, and these names down here are telling us that there's, again, different bacterial groups present depending on the time of year. And so what you see here is what happens after the milk is pasteurized. Again, it's going to be safe. What we're looking at are the remaining microbes that can survive through pasteurization over the course of a day in individual pieces of equipment at a dairy processing facility. So you can see when we look in the built environment, whether it be our homes, in food processing facilities, there will be microbes there, and the idea is how we can control them, and in this case, to prevent product defects. So we asked that question, again, not for olives, but for cheese. How is there a way forward in thinking about how we can understand defects that could happen in our dairy products? So cheese has been studied for many years. We understand many aspects of cheese, but we still have a lot of questions. And particularly when we're scaling up, as we're trying to do, as we want to make these foods more widely available, there will be issues. This is a living food. So what we wanted to look at is were there certain bacteria, microbes, associated with defects in cheddar cheese. And cheddar cheese sometimes has slits or cracks. And so we wanted to understand if maybe there was a microbial cause to that. So we looked at cheese and the milk that was used to make that cheese. And again, using microbial DNA sequencing methods, we asked what bacteria are present in cheese that doesn't have defect and cheese that does. And we found differences. And so that's what we're looking at here. On the left are is milk, and on the right is cheese. On the left side is cheese without the slit defect, and on the right would be that resulted in defects. So this is the milk that was used to make that cheese, pre and post the final pasteurization step, and then we're looking at the microbes in a similar way in the cheese. And you can see these names of Lactobacillus, Clostridium, Enterococcus microbes we expect to be there, but we see this difference. In some cases, we see enrichment of these bacteria genera that could be associated with defects. And so what we did in order to test this is we isolated the bacteria that we thought could be responsible for the slit defect. In this case, we really looked at heterofermentative LAV. They make carbon dioxide. And we also took that milk where we had mixed community of microbes, and that milk, we knew, resulted in cheese with slits. We inoculated either the individual strains or the consortia of microbes back into the cheese and made new cheese. And then we asked several weeks later, was there a defect? And in fact, we were able to confirm that heterofermentative lactic acid bacteria, example here is Lactobacillus fermentum, makes carbon dioxide and can explain that slit defect. This is one of those microbes that was enriched in the slit containing cheese. The same thing happened when we took that undefined consortia of bacteria that was in the milk and we put it into our cheese, and we see again, if you look here, these holes, that's our signs for defects. Again, we don't have the solution yet how to prevent and stop this from happening ever again, but we have the information now. We know which microbes to look for as that milk is being pasteurized and made into cheese, so we can identify problematic and potentially spoilage susceptible cheese. Okay, so with those examples, hopefully you get a picture of as we move from home fermentation to wanting to sell in large scale, the issues we're going to face with living foods. We have to identify what microbes cause the problem, and then we need to come up with solutions and how to stop them from causing the problems and get the kinds of foods we need. So the second part of my talk, I want to bring with you this idea of the healthfulness of fermented foods. So thinking about this idea of whether fermented foods bring something more than just the basic nutrition of the starting ingredients, whether it be milk or cabbage or cucumbers that we're starting with. So first of all, we just want to enjoy fermented foods. So there is that enjoyment and sensory experience from chocolate to wine to beer, I mean, really the best foods. No bias here. So sensory can be indulgent. It's not necessarily healthy. We want to think it's healthy. Fermented foods have also served a really important purpose for our health, and that is safety. We know important foodborne pathogens are not going to grow in high acid foods, so that is really help protect our food supply, even before we knew that's what it was doing. So they do deliver safety. They also are important for preserving nutrition. For example, Captain Cook gave sauerkraut to his crew, and because that retained vitamin C in their diet, the sailors no longer got scurvy. So we've known and we can appreciate these aspects of fermented foods. We've known about this for years. We don't necessarily need them for this, right? We can reuse refrigerators, we can eat fresh fruits and vegetables. They are important to the history of fermented foods. However, we want to also think, can they bring something more than that? Can they make us healthy, live long lives, and keep us free from chronic disease? And so we start to think, and this is just kind of what I've shown before, just a general outline for making fermented foods, the products we'll get, the sensory, but what about these things? So fermented foods transform food ingredients. Through fermented foods, we might get new bioactives, and through some fermented foods, we're increasing the number of living microorganisms in our diet. So what do I mean by this? So first of all, with fermented foods, we are getting transformation of the milk, of the meat, of the fruits and vegetables. We get this in several ways. So just a couple examples. So one way is maybe reducing toxic compounds. So rye and grains can contain phytic acid, which is an anti-nutrient, which will prevent absorption of minerals in the digestive tract. And so through fermentation, we can remove that phytic acid. Also, transformation happens when we increase the digestibility of fermented foods. For example, reduction of lactose concentration in fermented dairy products, removing sugars that cause flatulence. and things like weaning foods all increase the digestibility that makes it more accessible and causes less gastrointestinal upset. So that's transformation. Through fermented foods, we can also get synthesis of new compounds, and that can be through increasing vitamin content. We know some yeast and lactic acid bacteria can make B vitamins, so we can increase that. We also might increase neurotransmitters like GABA in fermented foods or conjugated linoleic acid in fermented dairy. We might also end up with metabolites that our bodies can't digest but are eaten by our own gut microbes that feed the gut microbiome, and these we call prebiotics. So those can also be made, synthesized through food fermentation. And lastly, we think of some fermented foods as sources of living microorganisms. So that's not going to be all. It's not going to be bread, for example, because we are baking it. But things like sauerkraut, pickles, kimchi, fermented olives, yogurt, and cheese will all have living microbes. And by consuming these fermented foods, we are increasing microorganisms in our diet by up to 10,000-fold. Maybe at some time we're thinking, and we're not there yet, maybe we say that for the discussion, but do we need a recommended daily allowance of microbes in our diet? Foods like yogurt, we know containing living lactic acid bacteria, we often see this live and active culture. So that's a sign that there are living microbes there. We know that many of these microbes can survive in our digestive tract, or at least they make it out to the other end. So as we study our gut microbiota, through collecting poop samples, we can look at what bacteria and fungi make it through from our food. So what this complicated set of figures here shows is that we're able to detect the microorganisms, the fungi and the bacteria in fermented foods in human stool. So that's the first sign that these microbes are not just in the food, but they're making it through to the other end. And this brings me back to lactic acid bacteria, this really important group of organisms making many of our fermented foods, at least having a hand in everything. Really diverse group of bacteria. You can see some of the names. Maybe you recognize them up here: Lactobacillus, Streptococcus, Enococcus, Leuconostoc. Some I've mentioned already. This group of bacteria we can find in many places. We can find them in the digestive tract of humans, animals, insects. We can find them on plants, even in water, and of course our fermented foods. And one genera of lactic acid bacteria you might have also heard of being probiotics. So that kind of brings together this idea of health and fermented foods and probiotics. But you see, my qualification here is that certain strains of Lactobacillus are used as probiotics. Not that all Lactobacillus in fermented foods are probiotic. There's a difference, so keep that in mind. So what we don't know yet, what are the ideas that we need to tackle? We need to understand better how exactly healthy are fermented foods for us, whether it be kombucha or even yogurt. Right now we're lacking on well-designed human studies, crossover design, the kind that we need to prove efficacy of anything. So what I'm showing here is a summary of diseases that have been studied in relation to fermented foods, meaning can fermented foods prevent or help in some way individuals with these conditions. And in most of these studies, there was a net positive outcome of fermented food consumption. But you can see just a few products listed. You don't see, of course, the thousands of fermented foods we have. So we really have a lot of questions I'm not going to be able to answer for you today on how healthy these foods are. We can break them down, we can study their individual components, so that has value. But when we put them together and we eat them as a whole food, we appreciate the need to understand this better. The other thing I want to bring up as what we need to know is the variation, even within a single fermented food. If you make kombucha at home, you might know that your kombucha tastes different from your friends, or if you're making sourdough or pickles, there are a lot of differences. And that comes down to subspecies differences among bacteria. Bacteria are really diverse. Even what you see here is Lactobacillus plantarum, several different strains. Their names are at the tops. We give them really ridiculous names you can't really remember. But these are all Lactobacillus plantarum strains that we isolated. We looked at their capacity to grow on different sugars, tolerate different stresses. They're very different from one another. They're not only different in their capacity to grow in a food and their general properties, but they also elicit very different immune responses in us. It's a little daunting, because if you think of Lactobacillus plantarum, that's just a name. We have to really look down at the strain level. Bacteria are very diverse. And lastly, put this together as we take this clinical study, we break down to understand their strain differences, what happens in our intestine, what happens in our bodies whenever we consume fermented foods, and we can consume fermented foods with living microbes. We need to ask questions. What are the specific things they're doing in our intestines or in our foods that are going to affect any number of pathways from our intestinal barrier, our immune system, our metabolism, and signaling between our gut and our brain? Some of this might be through communicating with the gut microbes that we have. Some might just be communicating directly with our bodies. And we only have a small idea right now of a narrow view on what these things could be, these specific communication molecules that are happening either with the gut, interacting with the gut microbes or ourselves. I'm showing them here in this slide. We're giving a bunch of names, and I'd like to see more. It's still relatively small. One example that, and this is it, this is the last example I have where we're starting to tease this apart at the strain level, at the species level, and thinking in whole foods how these microbes can really impact our health at the molecular level. We're looking at peptides made by Lactobacillus plantarum. They're shown here. And they're generally known to be antimicrobial. They're antibacterial peptides. What we found is that they're also immunomodulatory. We found that when we apply them onto epithelial cells, just those peptides, we get a reinforcement of the epithelial barrier. So we think by looking at these individual components that we can start to say, okay, maybe more strains than this one have this particular bacteriocin. We can start to maybe generalize and bring it back up to put a bigger picture together of what's happening with our fermented foods. So where do we go from here? First of all, education. We need to increase awareness, and right now we're involved here at developing materials. So how to make fermented foods safely at home. I think that's important. Safety is crucial. So general education, academic research, little plug. Of course, these are big questions. How do we solve 21st century challenges in agriculture? We need to really think not only at the industrial level, we need to think at the human health level, and to make these foods in enough quantities for everybody to enjoy and make them healthy. And I wanted to put a little plug in for the next speaker and his lovely product out there, and we were able to identify some of the microbes you can see here in his great sauerkraut. So I want to end and thank you for your attention, and acknowledge my funding sources, and as Dr. Waterhouse said, all of the people in my lab who've done this work. So thank you.
I'm sure our speaker would love to answer a few questions if we move on to our next speaker. So, there we go.
Oh, I'm sorry, I totally got lost about the split and the cheese. Like, what's wrong with that? What are you talking about? It doesn't form even what?
So there's, of course, many different kinds of defects there can be in cheese, and the particular problem with it having a slit or crack that's not supposed to be there in cheddar is that it's difficult to slice. And when you're trying to make enough for food service, and it becomes, it's kind of a technological problem, but it is still a problem. But we could apply the same principles if we're looking at off flavors. Things not tasting right in cheese, we apply the same principles.
That makes sense. Thanks a lot.
Good, yeah.
Can you expand a little bit more how fermented foods can help with GABA and that affects the CNS system?
Right, so the question is about GABA and affecting, so GABA is a neurotransmitter, and you can find it in not high quantities, but you can find it as an end product of microbial metabolism in fermented foods. It's actually a way they make it in order to control pH inside their cells. So it's a real practical purpose for the organism. And so you need certain amino acids and you get that end product. And I think that's something we need to understand better, is how efficacious is that GABA in a fermented food for us.
It will have to pass the brain barrier, right? So the blood.
Right. And there is a great deal of signaling we know that happens. Our digestive tract is an immune center in our body, and it's also a nerve center in our body. So, yeah. Mm-hmm. Oh, yes.
Yes. I have a friend of mine who's in the Raw Milk Institute with her dairy. And what is your opinion of pasteurized versus the raw milk industry that's trying to use bacteria?
I would always say to drink the pasteurized milk, and I'm going to tell you why. First of all, safety, and so many foodborne outbreaks happen. A large number of foodborne outbreaks have happened because of drinking raw milk. Campylobacter is a good example. The other thing I would say is it doesn't mean it's probiotic if it's raw. There is no evidence of that. So if you're interested in having more microbes, right, and maybe there are other reasons, but that are given. But if you want to have microbes, have a fermented food like a yogurt, or have your microbes in another way. I haven't seen evidence that drinking raw milk is going to benefit. There's a much greater chance for harm. Yes.
What is the microbe retention rate for fermented foods?
Microbial retention
Rate.
rate. Explain.
So you've tracked microbes
Yes.
in it, you've tracked microbes out of the body. How many actually stay and get incorporated into
Good
us?
question. Yeah, I thought you were going to ask about fermented foods. I can answer both. But yeah, we've seen individual strains within a fermented food go up and down. But you mean inside the body. We know with some bacteria, particularly the lactobacillus, they survive quite well through the digestive tract. And they will persist for several days, or maybe a week. Certain, they're, like I said, they're all built a little differently, so I can't really generalize. They're not engrafting, so they're not forming, to our knowledge, in any way we can measure so far. They're definitely not taking over our gut, right? So they're not forming a stable population that's going to be there or months or years later. So we don't expect these microbes to be retained for any long period of time. No.
My name is Isik Şeker. I'm from Turkey, Istanbul. And I want to mention our typical drink of things. Name is boza.
Yeah.
Yeah, it's made of, the wheat and the bulgur, and it's a very famous fermented products. And it's very easy to produce at home. Yeah. And maybe it's the easy to drinkable things for the vegetarians or the other persons. We added sometimes sugar or pigments. Pigments is the special the grapes juice. It's boiled and become the drinkable things. I want to share this one.
Yeah, thanks for sharing. Yeah, Boza. I had a project that brought me to Bulgaria, and that's where I was introduced to it. And we have isolated lactic acid bacteria, some that show some pretty interesting properties out of Boza. And just to say, there's so many fermented foods out there that we don't know about, we haven't experienced here, that we should. And love to have access to. And then we have that rich microbial diversity, and I see potential. That's what I see in those foods, microbial potential in there. So yeah, thanks for sharing that. Yeah.
One more question. Move on. Any more? I thought I saw another question.
I've made several sourdough starters from different geographic locations, and at first they have particular characteristics of their own, but eventually I found that they become very
Similar?
homogeneous. Is there any hope for keeping things like that besides having, extreme separation?
Environment selects. So imagine what happens if you bring them in and whatever, maybe your home or the way you do it. Little things like humidity and and temperature and I'm losing it right now, but that could really affect which microbes are growing and be able to sustain that. I think you have the bigger point. And take your small sourdough example, is what happens, are we losing diversity in fermented foods? And I think that's another question, but kind of the idea, I know that there is a place in Belgium where they are preserving different sourdoughs to try to retain that diversity. So I don't really have, again, I'm not full of answers, but I think it's very interesting what you see as this convergence in microbial composition, and therefore, or the same kind of taste that you would get.
I've seen commercially that you purchase different sourdough starters
Correct.
from
Yeah.
Paris or...
Yeah.
Is it, once you bring them home, eventually they're going to go native, right?
They go native, yeah. So again, it could be that maybe the different microbes, but the way we're preparing, or you're preparing, could be kind of selecting for certain metabolites, certain attributes, whether it be the flavor compounds or how well they're rising and things like that could make a big difference. Yeah.
All right. Thank you, Maria. All right, so we've got our slides for our next speaker already up. So our next speaker is David Ehreth, who's trained as an electronic engineer, got his degree at Cal Poly, San Luis Obispo, and then had a 30-year career in telecommunications at Digital Telephone Systems. He created two more telecom companies, Optilink and Westwave Communications, where he was Vice President of Engineering, General Manager, Founder, and CEO. But started a second career. In 2004, he started Alexander Valley Gourmet brand of fresh, live culture pickles and sauerkraut that later became Sonoma Brinery. He's a pioneer in the fermented and live culture pickle shelf. Healdsburg, California-based Sonoma Brinery today has 30 employees and sells natural and fermented products to over 1,500 stores. Much more important than that, we actually can buy them here in Davis, California. Dave mentioned that when he was a kid, he would visit New York City with his father, who took him to pickle shops that sold fresh fermented pickles, and that's what inspired him to start his business. So Dave, your turn.
All right. This thing here, what do we do with that? That goes forward. Okay. Well, hi. I am who he said I am on a good day. And thank you for having me here, and thanks for coming down. My axis of interest in this is to make and sell products and basically reduce to practice what Maria was talking about here. In my background, I was an electronics engineer. I worked through the 80s and 90s, and we made some companies, and the thing we did was to figure out how to bring lots of information out of the core of the network to homes back at a time when most of you had nothing but an analog telephone there. And we were looking at the problem from the point of view that data was going to grow. So anyway, as I worked my way through my career, I got used to the idea that if you have a problem, then, and if you understand the problem and you can characterize the problem, then there's going to be a definitive answer. And this is, and you know, digital electronics is so beautiful because you can get answers. It's not hard. And if something screws up, you can stop it and you go back and you say, oh, well, see, we set that to a 1, it should have been a 0, so there you go, that's our problem. You fix it, and you move on. And yes, complexity creates more and more problems and so on and so forth, but we built really big systems, and doggone it, they all worked. In fact, we had reliability specs that we had to meet that were really incredible. So I come into this world thinking, well, you know, if you have a problem, you just study it enough, then you find the answer, and then you just move to the next problem. And then I got into pickles. And so the story that you heard about my father introducing me to kosher pickles is true. I had sort of an absurd passion for kosher pickles, barrel fermented kosher pickles, no vinegar, lactic acid, and I don't know what it was that got under my skin about these things, but it did, and here I am. And I learned how to make them when I was this is pre-internet. I used to grow cucumbers and make pickles in the summertime, and then, you know how it is, you go out and plant all your cucumbers, they all come in at once. You make the pickles, and because these are fresh pickles, and they have a relatively short life cycle, at least the half-sour kosher pickle, which is the king of pickles, has the short life cycle. You have to find a place to unload these things, so you go around to your neighbors and ring the doorbell and drop a jar of pickles on their doorstep and take off. And you know, people said, well, you know, these are really good. How did you do that? And I said, well, I don't know. I put it in salt, and you know, next thing you know, they turn into pickles, and we eat them. So you should make those commercially. And so there came a point in my career where, after doing a bunch of telecommunications and getting to the point where I thought I was retired, I decided, okay, well, I think, you know, what I'll do here is I'll make some pickles. And I used to make them, and I'd drive them around, literally in the garage, and drive them around, put them in stores. And I was the only guy making fermented pickles, and or half-sour fermented pickle, and the only guy making fermented retail pickles in California. So that was pretty good, and you know, find a niche and exploit it and fill it, and so off I went. So next thing you know, what started off as a little hobby turns into this, and now I got 30 employees, and you know, I got payroll, and I got taxes, and I got all this other stuff, and that's the easy part, because what I came to find after working this a bit was that we were actually, I didn't realize what we were doing, but we were really pioneering a whole new thing. And if you think about it, it's nothing more than the evolution of food that we've seen almost every sector of the grocery store. Imagine when I was a kid, and for once I'm not the oldest guy in the room, I see some other people out here who would know what the store looked like when I was a kid. And you walked in, and if you said, I would like some yogurt, it was assumed you were a European communist. And, you know, today when you walk in and look for yogurt, you know, there's a whole category of yogurt in the store. This is a good thing. When I walked into the first guy that I ever sold pickles to, I went in and I saw a bunch of pickles there that were what I'll call industrial pickles, because I believe that this term means they were heat processed or chemically treated or whatever. And so I looked at what I was doing, and I realized intuitively that there was something very distinct about this. And then as I got further into it and I started making sauerkraut and one thing led to another and pretty soon getting into fermentation in a anecdotal sort of a way, the way you would in your own home. I mean, you go into your kitchen, chop up some cabbage, a little salt, put it in a jar, come back, and if you're lucky, you got sauerkraut. And I thought, well, this is great. And what I came to realize was we were building out a whole new thing. So when we go back to the dawn of man and we were talking about the early arrival of fermentation, the original solar energy where you took something that you made in the summertime and you got to eat it in the winter. You got to store it. You converted literally an example, like for that matter, like petroleum, but this is really a form of solar energy that comes forward and you get to eat it later on, and the mechanism through which you preserve is acidification, and the acidification is a result of bacterial metabolism of the things that Maria was talking about. Great. That was good. Now, right up to the sort of Industrial Revolution, everything was fermented. There really wasn't vinegar in the kind of proportion that we see it today, and it was only after World War II that we really saw vinegar become an important player. And combined with canning technologies and various other mechanization, we end up with the industrial pickle that you can get today on your McDonald's hamburger. And what I realized as I started looking at this more or less as I got into it and became aware that what I was doing was a lot different than what was on the shelf, we began to realize that we're doing something that's different. And what we're doing different is we're getting rid of the chemical component of pickling. We're using really traditional methodologies to produce unique flavors and freshness and the kind of thing that you don't get when you take something that's a year and a half old or two. And commercial sauerkraut on average is about 2 years old. So when you get it out of the can there or at the ballpark, there's not much similarity between what I make and that sauerkraut, except that it both is made with cabbage and at least originally was fermented. So as we go along here, we think, this is great because not only are we making something that tastes good, it's really good for you, or at least that's what Maria told me. And I didn't know that. And in fact, when I first heard people start to talk about probiotics and the gut biome and what have you, I, being skeptical by nature, thought, yeah, okay, whatever. I'm making these things because they taste really good. And that's where you can look at me and see that taste plays a big role in my life. And so I started to realize that there was another dimension to what we were doing, and it was the nutritional dimension. And then a big transition came over me anyway when I got really into dedicating my own personal capital to building a company dedicated to fermentation. And, we wanted to make pickles and sauerkraut, the best possible pickles and sauerkraut measured by taste, texture, appearance, and nutrition. And what could possibly go wrong? So here's a few things that can go wrong. This is a ton of pickles lying on the floor, and that is some version of Saccharomyces cerevisiae over there, which is one of the things that really is a problem in my industry. And this begins to, now I'm beginning to converge with Maria and the work that she's doing, because all of a sudden I went from realizing thinking that I was a pickle maker to realizing that what I really am is a bacteria farmer. And what you can't see really well, this right here is a picture from my microscope, and that is my crop right there. And those things that you probably can't see very well, little gizmos, those are the bacteria that Maria was talking about. And primarily in this case, Lactobacillus plantarum. And when I remember looking in that microscope for the first time, having never done that. I was a physics guy and electronics and determinism and all those things meant a lot to me. And then I looked in a microscope, and I got this phase contrast microscope, and I looked in there, and I couldn't believe my eyes. There's all these bacteria. And I was watching one, and I swear, some of these bacteria are motile, and they cruise around with their little flagella. And one of them turned left. And I thought, wow, if I had built, with all my electronic skills and some software and everything else I learned how to do in the many years that I worked in that industry, if I had built something that walked along and then detected something or other that it didn't like, and so it turned left, I hope you'd be impressed. Because I can tell you that with all of my skills combined, I'd struggle to make that thing. I could probably make something that would turn left, but that would evaluate circumstances and make decisions and do things in response to that and factor in myriad conditions and then respond in ways that I didn't even know they could. That would be quite a machine to build. And so I, being kind of a nerd and not having much else to do with my life, I started to read on the subject of microbiology. And my slides, by the way, didn't turn out so good here because we're compressed. So normally when I give a talk like this, the pictures are over there and the text is over there. So I just want you to take that into account when you grade this paper when I'm done. So off I went. I got into the books. I threw out the microprocessor. In comes the microbiology. I mean, you look into a drop of the biota coming out of a sauerkraut container. It is staggering. And anybody who thinks they're a vegan, by the way, this is one of the things. I have a very close friend who is a vegan, and she and I eat together very often, and she's very, very lectury to me about me eating pigs and chickens and cows and all that other stuff that I eat. And I just have to tell her, at least I'm killing one thing. You just killed a couple trillion things, and I feel good about myself. So anyway, so off we went. In comes the incubator, this and that, and what happens very quickly when you're doing something like this is you come to realize I'm no longer in a world of determinism, I'm in a world of statistics. And it's no longer about can I eliminate these bacteria, it's can I encourage somehow these bacteria to do things that I would like them to do. And then those things will be at the expense of bacteria that I don't want, or my buddy up there, yeast, and suppress them. Am I ever going to get rid of yeast? No, there's no way I will ever get rid of yeast. Can I develop methodologies of fermentation that statistically yield economically viable results? I'll get back to you on that, but I'm getting there. And I think we're almost there. And the one thing about my company, I don't have any venture capital investors, so I don't have to go to a board meeting where I have to explain this every week. Oh yeah, we got it all solved. It's no problem. It's all worked out. It's not worked out, and it's never going to be worked out. And I think if you got anything from what Maria was talking about, the degree of complexity of the subject matter that we're dealing with here, even though, hey, this is just sauerkraut, it's just a pickle. The level of complexity there exceeds anything I've ever dealt with before. And as I dig further and further and further down and down and down into this thing, there's no point where the light comes on. See, if you have a microprocessor, it's so easy. You just say, if the lights on the room are on, then keep the door lock unlocked. And it does it. Not once, not twice, not 3 times, not 1,000 times, but always. In the world of microbiology, that light never comes on exactly. It's sort of, you can sort of get it to glow a little bit if you want, you know, and if you influence things a little bit this way or a little bit that way, you begin to see stuff happen. The big picture, anybody here in this room can go home tonight, chop up a head of cabbage, throw 2% salt by weight onto that cabbage, stuff it into a jar, get as much air out of there as you can, cover it up with something or other so no air gets on it. Come back a week later or 2 weeks later, you're probably going to have sauerkraut. And then, you know, if you sit down and you do that, repeat that 1,000 times, what you'll find is there's a very interesting set of statistics that'll come out. And in the process, you'll come across some really interesting colors and textures and odors and things that you may not find desirable. So, when there's something weird and it don't look good, who are you going to call? Maria. So this is where Dr. Marco comes in, and I, through common associations, I ended up giving Maria a call one day and chatted with her about this, and I thought, man, I better come over here and see if there's an answer. Because in the world of electronics, there's usually an answer. And you just go, you have to find it. You have to understand what your problem is, and then you go and you find the answer, and you're done. You go, move on. I came over and had what I'll call an enlightening, if not depressing, conversation with Maria about my problems. And then I went out into the world and I talked to Fred Bright over at the State University of North Carolina, and he's a guy that's done a lot of work in this area, in the Agricultural Research Service. I went up to Canada and I talked to Tony, what's his name? Tony, you know his name. Tony, he's got that big Hyacinth Research Lab up there, big microbiologist guy, very interesting guy. And what I didn't find were any real answers to my problems, or what were my problems. Well, I'll talk about that in a minute. The kinds of problems that you find, some of the things Maria talked about, the pectinolytic reaction, where you go and launch a bunch of sauerkraut. And when I say launch a bunch of sauerkraut, we process about 1.5 million pounds of cabbage every year, which is not a lot in the pickle business, but it's a lot, you know, if you're trying to put it in the back of your pickup truck or something. That's a lot of cabbage, I'm going to tell you what. And going to the dump with that in the back, and what people look at, you know, they look at you and you're shoveling sauerkraut into the dump. And along the way, by the way, sauerkraut's got juice in it, which is trailing out of the truck, leaving a trail all the way out to the dump, which fortunately isn't too far away from where I work. So we you know, really came across some things that were awful. Slime and then sometimes this idea of the organoleptic dimension of what we do with regard to the subspecies of the various bacteria. We get our produce these days, all of our cabbage comes from one farm, but our cucumbers come because we follow the sun with the cucumbers. Since we make fresh pickles, we have to make pickles 52 weeks a year. And that means we need fresh cucumbers 52 weeks a year, and that means we're violating the Whole Foods model of standing there with a pitchfork and our coveralls with our organic cucumbers. That's not the world of pickles, and it turns out that it's a very specialized crop. You have to go all over the place for it. And we were talking about sourdough a moment ago, a subject that I love. I have a little sourdough sitting on my counter. And the epiphytic bacteria from each of these areas represents different subspeciation that you can taste when you're making pickles. And when you do this, you can taste the difference. You can taste the difference when the seasons change on our cabbage because of the different amounts of sugars that are in the cabbage. And the reaction, I will assume that there's probably seasonality to the bacteria that are sitting on the epithelial layer of the cabbage, and that they change across the seasons. But because we get our cabbage from generally the same area, we probably have a more deterministic set of bacteria that we work with, and therefore the flavors in our sauerkraut don't vary quite as much as our pickles do, because they do come from a widely dispersed area. And so I guess the point of all this is that if, one of the things that underneath everything else, I think any of us who do anything, we want to feel like we're doing something that's good or important. And, you know, so in a day, if I look at myself in the pickle factory and I think, what am I doing here? I'm reminded pretty frequently by people who write in that we're making something that's good and that people enjoy. And then thinking further about it, Maria's points about the food supply of an ever-growing population on this planet and the amount of waste that occurs, the obvious need to improve our overall market basket of nutrition, and the role that fermented foods play in this, to me, all seems like a pretty important thing to do. And so I've been able to build this company from originally just thinking, man, I'd like to make some pickles, take them around, put them in the store, and I thought that was pretty cool. And over time have come to realize that what we're doing and what we did was we transformed a whole sector of the grocery, so that today if you go in there, and like that yogurt example that I gave, where, you know, in the 60s, you really would have to struggle to find something called yogurt, where today it's very commonplace with many different vendors, flavors, varieties, pitching all different sorts of bacterial, this and that. And if you go to the grocery store today and you look at the pickles and sauerkraut shelf and you measure it against the pickle and sauerkraut shelf that when I arrived there, where there were 2 things sitting there, and today there's 30 or 40 things sitting there. And then the growth to the left and the right of that with kombucha over here and some other, you know, I don't know. You had a picture of a natto in there. I have a funny story about a natto. I went to this thing called the Fermentation Festival, and the gal that was running the thing was a friend of mine, so I got to pick my spot. So I picked the spot right in the middle, and I was there with my son, and we're handing out pickles, and there's millions of people there. It was a very hot day, and I didn't think we were going to have to work this hard, but there were a lot of people that came to this event. And so I'm schlepping out these pickles, and pretty soon I'm going, ooh, man, I think my deodorant failed here or something. I'm just smelling something that's, I don't know, some bad combination of odors that I wouldn't, on a good day, associate with. And so I was holding my arms down, and I'm handing out pickles here. And I finally turned to my son and I said, boy, I think I need to go maybe wash up or something, because something's really bad. Something's wrong here. And what I came to find, of course, was that the guys next to us, we hadn't noticed this, because, and I know you might think that's hard to fathom why we wouldn't notice this, but we're in a show, there's millions of people coming up, and we're trying to keep up with the crowd, and I don't know who's over here. It's the annatto guys. And I became familiar with annatto on that day, and that's one of the fermented foods that I'll keep that one for later. But anyway, so my business is to produce food at a price that the average consumer can afford. I'm not a big fan of $12 little bags of probiotic sauerkraut and all this stuff. We produce food for the average consumer. And how you do that, then there's a real challenge underneath that, because those statistics I was talking about are real. And if we're going to bring you sauerkraut that you can afford to buy on a regular basis and thereby improve your diet, improve, I would argue sauerkraut's delicious, and be eating very healthy things, then there's a whole layer underneath of that, of the technology that we have used and developed, and the value of having UC Davis here, where I can reach over to Maria and her student population, who both have answers, and maybe not, their answers here are not in terms of, well, here's how you do this, but rather, what is the effect of something? And what are the constituents of things? Maria and her group have the answers to those sorts of things. And we can take that information back then and we can integrate it into our broader process. And as a result of my work in microbiology in general, just my own personal study, my work with Maria and her group of students, have led to the improvement of our processes to the point where we were at one point at about 60% waste. So if you just take anything and you divide through by 0.6 to determine what its actual cost is, it's huge. And we couldn't sustain, nor could anyone sustain, loss rates at that level. So we today are running at about 92%. It's Tony Savard, that's who I was trying to think of, Tony Savard. He's one of the specialists, like Maria and Fred Bright, and some of these other folks that have been concentrating their efforts in this area. And the value of that partnership is immense, because it's not, we're not working on a trade secret for my company, we're working on improving an industry and getting this industry to grow. And I believe that our success will result in a small way. We're not going to solve the world's problems, but we are going to help substantially improve the availability of food to the average person. We will be able to provide people who are less able to access energy in the form of electricity and refrigeration, and provide them with support and how you, or answers to the problems that I'm looking for would be of benefit to those people who are trying to preserve their summer crop during the non-growing season or for another period of time, and do so without refrigeration, because in fact our products don't really require refrigeration. We only refrigerate them to just slow the metabolism of the bacteria down so that we can make it last a little bit longer. We are improving the diet and health of the world around us, which again, it's a little thing. We're not changing everything, but we are making an important contribution to that. And I would argue we have taken something that used to be a white bread, Wonder Bread kind of a shelf, which was the old pickle shelf, and turning it into a bunch of baguettes and other things. So we've improved the texture, taste, everything of the products that we're dealing with. So that's what we do, and it really is an interesting partnership, because I'm over in a day changing fuses in a slicer, and I run over to my lab and I'm measuring pH and trying to titrate and running some equations that don't work and all this other stuff, and then I come over and dump a bunch of stuff on Maria, and she comes back with well, here's what you had in there, and we really do benefit from this relationship back and forth. So in any event, that's my story, and I'm sticking to it. So that's what you get out of me. And I
know it's getting late, but I'm sure there's a few burning questions here that I want to ask Dave.
Not real. Okay.
What's the secret to crispness?
Fresh.
Next
Now,
question.
can I want to expand on that for just a minute, because as you saw, Pickles 2.0 is really based on fresh, no heat, no chemicals. And I've been asked that question a million times, and I answer it, and people give me the same look of incredulity that you just gave me, which I appreciate and understand. But the fact is that we're doing here underneath my company, we did something else too, which is a build to order. So we only build things to order. You never get anything from us that is anything older than about 3 weeks. And as a result, when you get it from us, if you look at the bacterial colonies in our products, you will see that they're at or near their peak, or will go through their peak while you own them. So it's the art of fresh. Yes, sir.
Yes. After you've completed creating your sauerkraut and before you sell it to the public, do you pasteurize it?
No.
Thank you.
This is one of the big differentiators. We were among the first to not pasteurize what we put on the shelf there. Yes, ma'am.
On one of your slides, you said that you use salt and sometimes vinegar.
Yeah.
So the ones fermented with vinegar, do they have the same benefits as the pickles without? I pickled a lot, but I never use vinegar, so I wasn't sure if it's...
Okay, so the answer is, if you, on the organoleptic plane, yes, they taste really good. On the nutritional plane, they're probably arguably less nutritionally valuable to you. Our products are all, I mean, in my case, they're all natural, completely natural, meaning that they were either alive, they're water, or they were salt. And so, yes, so we don't get the probiotic value, but you do get the taste and everything. There was a question in the back there.
Yeah, I'm a happy customer, but I have a practical question about spoilage. I went into my fridge last night because I was going to come here you speak. I found a half-eaten batch of your pickles. Little stamp on the bottom said best by 3/12/19.
Yeah.
How long can I push that for?
Okay, are these, what kind of pickles were these?
Spicy bread and butter.
Spicy bread and butters. Yeah, you want to eat them by that best by date. And here's why. We use no antioxidants, and vinegar has a bad habit of oxidizing, and you can taste the drift as that vinegar begins to pick up an oxygen atom. And I personally don't like it, so eat them before the best. Yeah. Get on it. Yes, ma'am.
So how does learning the bacterial composition of your products from Maria help you with your statistics? How do you translate that into better?
It's not, again, this is a funny business because this is not, I've never gotten to a situation, and as much as I'm sure Maria would like to, she's not been able to say, well, you know, if you do exactly this and you do exactly that, you'll get exactly this. This is more about understanding bacterial composition, understanding the speed with which bacteria will acidify, and in particular in sauerkraut, it's extremely important to get sauerkraut to rapidly acidify. And sauerkraut goes through 3 sort of major phases, each noted by a particular type of bacteria. And so when we talk about what, you know, it's not, so how do I get my sauerkraut to acidify quickly is probably not exactly the answer or the right question. The right question is, what do Leuconostoc mesenteroides, the initiating bacteria in sauerkraut, how do we grow them better? How do we, you know, what can we do? And that's sort of how this exchange works, is how can we do that better? And this one little thing, and then, you know, a million other questions like that. But that's sort of the general flavor of it.
It's salt and cabbage. What do you do better?
Well, boy, it's salt, it's cabbage, it's the shape of the fermentation vehicle. Well, if you think about a square fermentation vehicle versus a round fermentation vehicle, and if you think of a vessel, a fermentation vessel, as being like a city where there's a bunch of neighborhoods and alleyways and what have you. There's all sorts of different things going on. So if you were to, for example, meticulously go through a tank of sauerkraut and do it in a way where you could just pick this right over here, and without disturbing anything else, you go over here and check this and check that. Early on in the development of the sauerkraut, before the great competition occurs between different bacterial strains that where they will actually kill each other, or maybe not so much kill each other as create an environment in which the other one finds unpleasant. We can influence those factors. Air is a consideration, and how you keep air off of your sauerkraut. And I mean, things like polypropylene plastic is highly permeable. So even though you have plastic on your sauerkraut, the permeability of that still allows enough oxygen to go through that you probably can benefit by not doing that, by using other factors. Temperature, the shape of the fermentation vessel, and on and on and on. And they're little things. I mean, it's funny. There's so many little things, but they all together work towards, again, the improvement of the statistics, considering that we're dealing with 1 trillion bacteria in there. Yes, ma'am.
Do you use an inoculum from a successful batch and carry it forward?
Well, unfortunately, in the case of sauerkraut, we don't, and we don't in general. We use epiphytic bacteria. But the sauerkraut in particular, you start off with Leuconostoc mesenteroides, and rapidly you go to Lactobacillus plantarum as the primary fermenter, and then if you go long enough, you have Lactobacillus brevis and Pediococcus pennisaceus as the final things, and even then, Acetobacter get in there and start making vinegar.
Because it sounds like it's a race, between competing armies, and so
It
if
is.
you can have your soldiers on the ready, if they're not harming what gets the whole thing started, they're there and they take off.
Well,
I don't know. It's just
so we thought, well, I got a great idea. Let's go get some Leuconostoc mesenteroides and we'll throw a lot of that on there. Well, it turns out that other people do that too. They do that to make dextrin. I don't know if you know about dextrin, but you grab the sauerkraut and you pull it out, and his great ropes of snot just come off, and so you really, it's just one of those things where you kind of, it's leave it alone. But again, when I say I'm a bacteria farmer, and that's what I really am first and foremost, it means that, yes, I know how to make pickles. But primarily, like the almond guy down the street here, or the corn guy, or the viticulturalist, it's about knowing what the roots are going to uptake and what you want from the finished product vis-a-vis the methodology that you're using to encourage the biological part of the process to go down a path that you ultimately will lead you to that desired result. And a farmer, I don't think you hear guys say, I'm an almondist or a pepperist. They are farmers. And so and I know that difference, it may sound sort of funny to say, what's Dave talking about here? He's got off the deep end, but the idea is, yes, we make pickles, yes, we make sauerkraut, but what we really are farmers. And you have to, we at least at my scale, you have to understand that and treat the farming process as the primary factor which will lead you to the desired result. So I hope that, I know it sounds funny, but it's how it is. So.
All right, that sounds like a great